So what could influence enzymes and how fast they catalyze reactions? You already told me about heat. But heat's problematic in biological systems. So while it does work, we have to worry about that effect on the system. We've talked pH. We've mentioned salts. These are the big ones that we look at. Because remember, if an enzyme is a protein, we need to focus on anything that would affect a protein. So pH, big, temperature, big, these are all things a protein is sensitive to. And if we change either one of them, it will change how the protein behaves and how the enzyme functions. Let's take these three enzymes that are in you right now. Pepsin, salivary amylase, and arginase. The pH scale along the bottom is where I want you to focus. Relative reaction rate is on your Y, so the higher the peak, the faster the reaction rate. Okay? If we start out with pepsin, the peak of that pepsin curve is at about a pH of 2. The peak of this salivary amylase curve is about 6.8, somewhere in here. The peak of the arginase curve fits at about 9.5. If these are all enzymes that are in your body right now, where could these enzymes possibly be functioning if they function at the highest rate at those very specific pHs? Where do you find a pH of 2 in you? Your stomach, right? What about a fairly neutral pH? Salivary is your key here. Be found in your mouth. And arginase, this is a fairly basic pH for us. So where would we need to have such a basic pH? One that might be buffering highly acidic things. This is actually associated with your small intestine. Why do we need your small intestine to have such a basic pH? Your stomach connects to your small intestine. If your stomach is pH of 2 and dumping pH 2 liquids into your small intestine, we need something to buffer that. And so your small intestine is about a pH of 9.5 or 10. Arginase, that helps to continue to break down your food, works perfectly at that pH. These kind of perfect environmental conditions are hard to come by, but in you, 37 degrees C or about 98.6 degrees Fahrenheit is an average body temperature, right? If we go above that, enzymes break down or denature. We've talked about denaturing proteins before. Enzymes denature. If you go below that, they don't always fall apart, but what we do look at is that all reaction rates slow down at colder temperatures and the enzymes will fail to function properly as well. So we look at most enzymes in your body kind of functioning at this perfect temperature of about 37 degrees C. So we see that most of the time. That doesn't mean that there aren't colder and warmer sections of your body that would allow them to function differently. But temperature and pH are big considerations for the proper functioning of enzymes.